now I want to talk to you about how we can determine if two lines are parallel or perpendicular. So what we're going to do is we're going to use this graph right here. I got two pairs of lines that we're going to demonstrate here with. The first pair of lines are parallel. You can tell that they're straight, they don't touch, they look like they're going to continue on forever. They're technically line segments, but we're going to prove that they're parallel. Now what I'm going to do here is I'm going to find the slope of each of these lines. Alright, so here's how we do this. I'm going to use the blue marker first for this first line. We're going to find the slope using the rise over the run. So I'm going to write over here, slope. And we're going to use the definition that it is the rise, which is your change in y, over the run, which is your change in x. So rise over run. Alright, and so what we find here is the rise, I rose 2 spaces or 2 units up. So this is 2, and I ran 1 unit. Alright, so this is about 1 unit up, or excuse me, to the right. Alright, and this is a positive line, so our slope here is going to be positive 2 over 1 or positive 2. Now, you're really going to see that these two lines are parallel when we take the slope of the second line. The second line goes like this. I'm going to go up as well, up to 2 over 1, and what I'm doing is I'm finding 2 points that are, I could go all the way up here, but I'm finding a point that lies right here on that cross section of the graph. So I went up 2 again, and I went to the right 1. So the slope of the green line is, again, rise over run, so it's going to be 2 over 1. So notice how the slopes are exactly the same. That is a key feature for parallel lines. The slope needs to be exactly the same. So I'm going to write that up here so that you have that. I'll write it here in green. No, blue's better. Parallel lines have the same slope. Alright. Now at this point you should know how to create equations of lines just by finding the slope and where they intersect the y-axis. If you don't know where it intersects the y-axis, just continue the line up until it hits the y-axis. Find that point and you create your equation. Filling it in this format. Okay? In this case, the slope of both of these equations would be 2. And for the second line, it hits the y-axis at 6. So that is where we cross the y-axis. So this is the equation of this second line. And the equation of the first line, if we continued it up, it would probably hit the y-axis somewhere in the 10-ish range. So we could do that. So this would be y equals 2x plus 10 would be our equations of these two lines. Now I know I just kind of breezed through that, but like I said, the purpose is to be able to identify parallel lines. You only need to find the slope of those lines and know they're identical to know they are parallel. Now for these two lines, they intersect, but there's always lines that intersect. These two lines in particular intersect in a special way. They intersect at 90 degrees, and we call them perpendicular. Now, in order to really actually tell if they're perpendicular, we're again going to take the slope of both these lines. I'm going to use red for this first line, and I'm going to start here at 2. I'm going to go up until I get to this intersection point right here, because I know that's the point where they cross. So it's going to go up, and we go up about 2. That's our rise, right? Our change in y. And I'm going to go to the right. And that takes me about 3 units to the right. So the slope for this particular graph, or for this particular line, is going to be 2, which is our rise, over 3. Okay? Now check out this last graph here. Now this particular one, actually I have to go down 3. Alright, so I'm going to go down 3 to get to this horizontal line right here. And then we're going to go across 2. So I'm going to go down 3 and across 2, and I'm going to write the slope here, the slope of this line. And it is down 3 and over 2. Now if you notice, this is a negative line, so I'm going to keep that slope negative. Another way you can think about it is you went down, so you went negative 3 instead of just 3. I find whatever you can figure out as far as tricks go, use that works for you. But notice here, they have the same numbers, however they are flipped. One is flipped, the other is not flipped, so to speak. They have opposite sides. This flipped notation, what we would call this, is they are reciprocals of each other. Alright? So when I write a definition for perpendicular lines, I say that the slopes are opposite, meaning opposite signs, one positive, one negative, and they are reciprocals, or in your terms, flipped. So perpendicular lines, and if I misspell this, pardon me, perpendicular lines have opposite and reciprocal. Opposite, reciprocal, or flipped. I'll put flipped here for you. Slopes. Alright. So watch this example over and over again as many times as you need. Try to get this familiar with you, and we'll try to check it out, see what happens next time. Alright? Cool beans.